In this video, we'll discuss characteristics of distance vector routing protocols. Distance vector routing protocols is a dynamic routing protocol that's responsible for dynamically updating neighboring devices with routing information. Now, these dynamic updates are periodic updates, so they're sent on a regular basis. For example, the RIP routing protocol sends these routing updates to neighboring devices every 30 seconds. And that is one of the disadvantages to some of these dynamic routing protocols is every 30 seconds, there's now this packet that's being delivered across the network using up bandwidth that's sending out routing updates. Now, with distance vector routing protocols, they communicate with neighboring routers. So any routers that your router is connected to, your router will send updates out to those routers. And then those routers will send updates out to any routers that those routers are connected to. So that's kind of what we mean by neighboring routers, is it's all based off physical connections and sending the update to those neighboring devices. Now, depending on the distance vector routing protocol, these updates are typically sent out as broadcast messages. Especially with the older distance vector routing protocols, it was all broadcast based. And again, that was kind of one of the downfalls to distance vector is the messages are broadcast out on the network. So the broadcast address is 255.255.255.255 that the updates is sent out to. Now, some of the newer protocols will use different techniques to deliver those updates out so that it's not broadcast based. One of the other characteristics of distance vector routing protocols is that it's the full routing table that's delivered as an update. And again, the older protocols would do the full table, and they've changed some of the newer protocols so that it's not always the full routing table that's delivered out. But that's a very important characteristic of distance vector is that entire routing table being delivered versus just the update itself, right? So that adds to the utilization of your bandwidth as well as every 30 seconds, the full routing table being delivered. There's a number of different distance vector routing protocols that are out there, and two of the more popular ones over the years has been the RIP routing protocol. That's a very common distance vector routing protocol, and also IGRP is another very common distance vector routing protocol. So these guys are all responsible for sending updates on a regular basis, full routing table being delivered. But those are just two of the common ones. There's a number of other ones, right? So everything that I've talked about so far has always been about IP-based layer 3 functionality. But just as kind of a side note there, you can see that there's an IPX RIP, there's an XNS RIP. So there are other routing protocols, but RIP and IGRP being the two popular distance vector routing protocols that send updates to neighboring devices on a regular basis. Here we want to talk about the process for delivering those updates out. So you can see here that we have three routers in the diagram, right? So I'll use the top router as my context here for the discussion. But the idea is that when this router powers up, it identifies any of its connected interfaces, right? So it identifies the interfaces that are connected to it, the IPs that are associated to it, and what happens is it builds the routing tables of the routes that this router would know of. So by default, routers know about anything they're connected to. So this first router at the top here would know about this network, and it would also know about this network. So whatever the IP ranges are for both of those networks, it would add those to the routing table. And then what would happen is on a regular basis with distance vector, so let's assume we're using RIP. So every 30 seconds, this router up top here would send updates out to the neighboring devices, so the neighboring routers. So it would send an update down to this router saying, hey, I know of, network 1 and network 2, right? And it would send the update down here to this router saying, I know of network 1 and network 2. And then these routers would be responsible for communicating the updates to anything that they're connected to, right? Not just updates, but the routing knowledge, I should say. So it passes that information over to neighboring devices. Now, also what's important here is the router that receives the update itself. So again, this top rotor here sends the update down to this rotor on the left-hand side. When that rotor on the left-hand side receives the update, the first thing that it's responsible for doing is to apply the update to its routing table. So if it's knowledge of a new route, then a new route is created in the routing table. But if it's maybe an update to an existing route, right, it would modify the existing route and update things like the metric value. The metric value is specifying what the best pathway is to a destination. And with distance vector routing protocols, they use what they call a hop count, right? So it's how many rotors away is that network. So for instance, to reach this top rotor here from this bottom right-hand rotor, we could go 1 hop direct, right? Or we could go 2 hops, 1, 2. So this bottom right-hand corner rotor, it would update its metric information with the hop count of what the best possible pathway is to reach that destination. So that's what happens when a rotor receives the update message, is it goes and update its routing table with that information, and then also that includes updating the hop count. So in this video, we discuss characteristics of distance vector routing protocols.